All right, my friends, here we are, Lecture 5 in the class on uncertainty and probability. Today, Induction and Intellection. We're going to be going over Chapter 3 in my book by the same title, and it is all about induction and about intellection. Well, why is this important? Because people say, and it's true, as you can sort of see on the board there if you're glancing ahead, that probability is a type of induction. We have to be careful about this. There's some people out there who use the word induction differently than I am going to use it. In fact, we're going to be very careful about the word. There's people like Carnap and everything who use the term inductive probability and so forth. I don't agree with these uses. I don't find them helpful in understanding what probability is. We're going to do this. We're going to do this today. Dropping chalk already. We're going to do this today, and then the good news is next week we finally start, 6 weeks into the thing, we finally start probability. We'll be going back to Jaynes. We're going to go back to Jaynes, and we're going to go over Cox's theorem, and we're going to start proving some things about probability. We need all of this, though, for reasons you're going to see today. We need to understand exactly what uncertainty is. And if we don't know what certainty is, we can't know what uncertainty is. So we have to start with certainty. And there's no more certain knowledge than is brought to us by induction. Now, you remember the thinking is logic is the highest form of knowledge or something like this. Rationalists believe this. Well, it's not true, because you can't know the rules of logic are useful unless you first have induction. So let's do that. Now, I'm not going to, let's talk about what I'm not going to do. There is the idea of justifying induction that people say, we need to justify induction before we can use it. Well, no. We could have a truth. Suppose there's some proposition out there, A, we'll call it A. It's necessarily true. It's absolutely true. It being true and somebody proving it true are two entirely different things. We do not make the propositions necessarily, any proposition necessarily true. They're necessarily true by virtue of themselves. They're caused to be true because that is the way things are. And there has to be a cause for that. Well, we can get into why there's a cause for that. We'll do all that another time. But we do not make things true, except in local truths. But necessary truths are true, all right? And our knowledge of them is different from the way they are. We got to keep those things separate. That's what I said on day one. We have an ontology, the way things are, and we have our epistemology, which is our knowledge of the way things are. Okay, so some people will say they're going to justify induction. No, that just means proving to skeptics that induction has uses, and there turned out to be skepticism because of people like David Hume. Now, there's no better foil for Hume than David Stove, both Davids. This rationality of induction we've been drawing upon is one essential text to read. He's got others. We'll talk about those. But if you want to know why Hume made the mistake he did, we just don't have time. Maybe we'll have a diversion sometime in the future or something like this, because it gets very intricate very quickly. But fascinating reading. There's 3 versions of this book. I can't lay my hands on the other one. I don't know where I put it. They're all the same book by David Stove. Scientific Irrationalism, Origins of a Postmodern Cult. I think the second term, or the first one, was Popper and After for Modern Irrationalists. And then the American version is Anything Goes, Origins of the Cult of Scientific Irrationalism. This has a wonderful first section of the book called Sabotaging Logical Expressions. It's where we learn the term scare quote. You've all seen scare quotes, meaning not true. A sentence in scare quotes is not true, but believed by so-and-so to be true. It's a way of sabotaging logical expressions. And then the second half of the book is a very subtle, detailed, intricate argument to show how David Hume made his mistake about induction. Basically, to wrap it all up, he believed the only valid forms of reasoning were deductive. Well, How could he prove that? He can't prove that. He can only prove that using induction. So he fails on his own circularity argument, if you like. So, all right, now the book we are going to use today. This is a really good book. I think it has a second edition. I have the first. I don't have the second edition. It's by Louis Groark. It's an Aristotelian account of induction. I don't know if you can see that with the shininess of the sun there. It almost come out once. It was a miracle. But of course it went back away. Don't get to see the sun here in the north until sometime in June. Anyway, this book here is wonderful. It goes through all about induction. And like everything else, it starts with Aristotle. And what the idea is that we've been looking at induction too simply. It's not just the one form of induction, the very least form of induction, like a probability kind of induction. It has at least 5 different shades or ways to think about induction. So I've kind of written them up on the board here. We'll go through them all, and I've kind of renamed them slightly to make them fit in with the rest of the book. But before we do this, we have to have just a very slight digression into metaphysics. We need a metaphysics. We're going to be talking about science. Now, science, for instance, a doctor invents a new pill to cure some dread disease, the screaming willies or something. And he is going to give this pill to various people, right? He's going to pick people out. He's going to give person 1 this pill, person 2 this pill, person 3 this pill. Aha! How does he know the objects, the entities which he's giving the pill are people? Aha. Well, it's obvious. We use this form of reasoning so intuitively, so behind the scenes, we don't think about it. But it involves an induction. It involves the idea that we know the difference between a person and a cat. Well, up until a couple of years ago, Western society did know the difference between a person and a cat. Now we pretend not to know because of other reasons we're not going to discuss here today. And the reason we know is because of induction. We'll talk about that. And the idea is simple. We're going to talk about the hylomorphic metaphysical account. That is to say, things have essences. Things have a nature. And it's our goal to understand the nature of things. It's not just the nature of parts of a thing, but the powers a thing has. And when we speak of the powers of a thing has, we're going to be talking about causality, and that's a very important subject in probability because many people make mistakes. So we're not going to go all through this today. I'm just going to tell you. The rival is nominalism, which says that there's no real essences. Everything is just particularities and so forth. But it's not true. I mean, the old standby argument is you have a triangle. Everybody knows what a triangle is. It's a 3-sided planed figure where the interior angles add to 180 degrees. We know the essence of a triangle, which we induced from simpler mathematical objects or geometrical objects. Well, this particular triangle has accidents, little deviations from the essence of a pure triangle. It's yellow. It could have been, could have done one in red. This one has a particular shape. I could have done, I can't get the figure exactly right. It has small deviations from exact perfect straightness and all this kind of thing. There's little accidents that move it away from perfect deviations, but we recognize this is a triangle and that this is a square, and we recognize they're not the same. And the people who say they're not, they're just cultural, customs to say that they're different. Well, that's nominalism. We're not going to go with that because no scientist, they might on paper say they're nominalists, but nobody really believes in nominalism. No, even those professors that say they're nominalists don't believe in nominalists. I always use the joke, take away their, forget to pay them for a pay period, and you'll soon realize they're essentialists. They're nothing like a nominalist, all right? So this is all that kind of people have doubt on paper and so forth, but not in real life. All right. So now let's go through the forms of induction, which we need to do before we jump into probability, not jump into probability. We've been taking our time about this. Now, again, these all flow from Aristotle, who recognized at least 5 different ways that we use induction. And I've listed these here from those types of induction that give us the most certain beliefs that we have, down to the most uncertain but still certain types of beliefs that we have. All right. The idea is the last bit of metaphysics that we need is everything starts in the senses. We have our 5 senses, and we make observations. And from these observations, we move from these particularities, from individual observations that we have, to generalities. In other words, we see things as they are, and from these we extrapolate and we induce universalisms, essences, and so forth. All right. So, but we need our senses, of course, in order to start this train of thought. The only possible, the only deviation from this is something like revelation. And induction, I think, can be argued to be a form of revelation. So let's think about this. We have the highest forms, induction intellection. This is where we make abstractions. This is where we form our universals. We have these individual things that we see. We see people. We see shapes that are people. They're talking. They have 2 legs. They have 2 arms and this kind of stuff. And we move instantaneously to an infinite. The infinite being, this is what the essence of a thing is. And that instantaneous form of learning that we all do is, at least for universals and abstractions and the like, induction intellection. This is where the rules of logic come from. We induce that the rules of logic that we're using are valid and sound and formal in all that kind of ways that we discussed, or not formal in the ways we discussed. We can't use logic. We can't make any arguments at all without first starting from the belief that these ways we're arguing work, right? So logic is down a step from induction. There's just no way around this. You cannot say logic is a superior way of doing this without having first justified how logic works, and you can't do that without induction intellection. So we do touch the infinite. We do come to these we grasp these universals and everything, and it's always instantaneous. It's not to say, we're going to talk about it in a minute, that everybody gets the same has the same facility. We've talked about this before too. Not everybody can know the same thing. There's differences. All right, people have different abilities to sense these things. But very simple ones, all people share. Well, we can all speak or all know language. All right, the next thing down is intuition, induction intuition. This is where we see likenesses in things. We've already made the induction intellection about what the essence of a thing is, and here and now we can see a thing out there and we can get likenesses, and it's from this mathematical axioms and the like flow. And again, axioms. There's a way it's used in mathematics sometimes is to mean just assumption. I'm going to posit these particular propositions and I'm going to go to town and see what I can prove for them. There is that way of thinking about things. However, all of that kind of mathematics rests on simpler mathematics in which the axioms that we use to prove all the theorems from these simpler types of mathematics are believed. The axioms are absolutely believed as true. And there's no proof. There's no proof of any induction. That's one of Hume's complaints, that there's no proof of this. Of course, there's no empirical proof. There's no empirical proof that logic is good. That's what we did last week. Logic is not empirical. So we can't prove any of this by making some observation. No, we still always have to rely on faith. It's just absolute, if you want to call an induction a kind of faith. No problem in using that word, I think. It has a bad reputation in some places, as we saw last week, but there's absolutely no problem in using it. Now, Gödel's work I wanted to touch on it, only touch on it. I'm going to have, it's too much for us to go into it in this particular class. Although, again, we may do a sidebar kind of a topic. But basically what he proved is you can only get so far in mathematics before you have to make a new axiom, make a new assumption. Not everything in mathematics can be proved. Well, we know this is true because we start with things that we cannot prove are true. Axioms cannot be proved true. They have to be accepted. And they are accepted because we intuit their truth. Now, which mathematical axioms and so forth? Well, if you've had any kind of math, you've seen them. If not, you'll have to trust me on this. I gave us one of Pino's axioms, but there's lots of different axioms we could use. Intuition gives us ideas like the principle of non-contradiction in the room. Non-contradiction, the principle of non-contradiction, a logical belief. So, for instance, when we're very young, we see our mother's in the room, and then she's out of the room. Well, from individual instances like that, we grasp by intuition the principle of non-contradiction. Mom can't be in the room and out of the room at the same time. And there's no rescuing this, as we'll see later on in quantum mechanics, by saying something is here and it's not here at the same time. It doesn't work like that. There's nice solutions to this. We don't need any of that nonsense, which we'll come to. Induction argument. Scientists use this one all the time. This here is an electron. I'm going to do an experiment on some electron, and I'm going to argue that the very next electron I'm going to repeat the experiment on is just like this electron. And the third electron is just like the first electron, and so on and so forth. In fact, that becomes an axiom in itself. Right? So this is the form of argument we're using. It's the same argument the doctor's using when he's giving his pills to different people, and not some to some cats, and not some to his Buick Skylark, and not some to put on a chair and see what happens. He doesn't do that. All right, so we all have that kind of a thing. And the next one down is analogy. Analogies are fun. Analogy. This is one of my favorite lawyer jokes. This is where we get comedy. Lawyer jokes. A bad lawyer is one who makes a case drag on for years. A good lawyer is one who makes it last even longer than that. That's my favorite lawyer joke. So from analogy, we get stereotypes. And the gentleman, Stephen Goldberg, who wrote the introduction to uncertainty for me, now deceased, God rest him, he has books called Fads and Fallacies in the Name of Social Science, and I'm forgetting the other one. Oh boy, my mind is shot. But he basically has nice long arguments proving, and we're going to go over one here in a minute. Stereotypes are true. Almost always. But what causes stereotypes, what causes stereotypes is not always true in people's minds. People can identify correctly stereotypes, all right? But it doesn't mean they've nailed why the stereotype exists. That's a different form of reasoning, and we'll see that often in science. And finally, the very last, the one that provides the least certain form of knowledge, of course, is probability, which we see correlations and we argue from correlations and so forth. It's where we take the idea that samples resemble their populations. And how do they resemble them? Well, in the cause, in their causal ways. And remember, we have to talk about cause more in depth later, which we will. Cause has 4 parts. There's a formal cause, a material, an efficient, and a kind of a directing or overall purposeful or some final cause. We need to think about cause and all that kind of a thing. So there's probability type cause. And so most of the time, when you take a class in statistics and probability, they jump right into this. They start shoving math, and they never tell you what this math means or why you're using it or anything like this. They're just going to let you go on your intuitions. And so, Briggs, didn't you just say that intuitions are good? Yes, but now why do people have a problem with induction? Because somebody recognized this mistake, and this is what this Taleb, the great blocker Taleb, had a book called The Black Swan. They used to argue back in logic a long time ago, all swans are white, and, Bob is a swan, Therefore, Bob is white. Well, it turned out, and when they got to Australia and to the Antipodes, they found a black swan, and that, oh my goodness, we've just upset all of induction. We now have no ground for induction. Oh, nature is not uniform, and everybody started weeping tears. This is great nonsense because, look, of course people are going to make a mistake in any one of these forms of induction. They make mistakes in logic all the time. These same professors who think that there's problems with induction, they grade students' papers, logic papers. And the number of ways students can go wrong in logic is boundless. It may actually be infinite. Nobody knows. But nobody says, well, therefore, let's throw out logic. You say we make mistakes in one way. It doesn't call into question logic and mathematics because some students or some people get it wrong. They get induction wrong. They get logic wrong. They get math wrong. It doesn't mean that the basis is unsound. So that's a canard if there ever was one. All right. In fact, as long as we're talking about this, I did. Yes. So let's do an analogy probability example, and I'm taking this from Steve, and I'll erase this first, and then I'll draw up a couple of pictures. And this one's kind of popular. This one's kind of popular on the internet and everything. So we'll see. As before, I'll have an excerpt of the book on my. On the site, on my blog, and on the Substack and everything, so you'll be able to read all this. There is a subject called GRU that's supposed to cast bad light on induction and everything. I don't think it does. I think it brings us too far afield, and probably it would bore a lot of you, so I'm not going to talk about this. I go in and I show you why I don't think GRU is any kind of a problem. If you've heard of it and you understand it, you can go in and read this, and it has to do with misunderstanding cause. It has to do with misunderstanding a portion, one of those aspects of cause in induction. You can induce one thing, but you can't mix up your types of causes, and that's what I think happens with GRU. All right. Now, everybody knows we could say, well, men are taller than women. What does that mean? It doesn't mean that every single man is taller than every single woman, right? It only means this. And I'm going to write it up. I know some people can't hear me when I point at the board, so I'm not going to speak, but I'll just write it up on the board. I'll say it in words first, and then I'll write up the equation. If we have two people, A and B, and all we know about them is that A is a man and B is a woman, that's all we know. Someone just told us about these people. And given what we have induced about heights, our general knowledge that we have induced about heights, all this means is the probability that A is taller than B, given what we've known about heights, is greater than 50%. Now, I haven't introduced probability or proved to you that we could use probability in this way. And I haven't told you about the conditionality of probability or any of that, but I'm going to write it up anyway, and we'll see later on that what I said was true. All right. The probability that A, the man, given what we've induced about the essence of human beings, so we have the essence of height, given what we have induced, we've used induction to get the idea about the essence that we have about human height, the probability, knowing only this, that A is taller than B is going to be greater than 50%. That's it. That's all this type of induction is. And so you got to be careful. A lot of you've seen the mistakes people make about this. Somebody will say, well, I'm a woman and I'm taller than so-and-so who's a man. Okay. Well, okay. That's true, probably. Who even knows, though, with the way things are going these days. But that does not take away from the essence that men are larger than women. This is just a fact. In essence, not in every particularity, okay? So we've gone from the induction. Now we're saying something about also about the generality. We're not saying something about individual people. Once we learn this is a woman, I guess they have women basketball. All the propaganda has been out pushing this kind of a stuff. So, and this guy over here is, a Harvard, studies major or something like this. Well, this guy's going to be weak, small, puny, diminutive. Well, this woman's going to be tall, Amazonian, tall. So yes, once we know that, the probability that the man is taller than the woman is 0, because we've observed the opposite. But the essence would stay the same. This probability would stay the same. So there's another error that people make in this. Let me just draw this up. And again, I'm using facts I have not yet proved, but I will get to them. You've seen these kind of diagrams before and so forth, and I haven't showed you what they even are, how to use them, and justified them in the sense that I can prove them and all that. But I'll do it here. So let's use, this is kind of pinkish. We'll use this for women. Here's the distribution of women's heights. In other words, we go out and we collect a lot of women. We see most of them are about this tall, and some are this tall, and some are, this tall. So we could collect them and count them and then make a distribution of them. It might look like this. Something like that. All right. That's women. Meaning the average height is somewhere around there. Men, on the other hand, we can go out and find men. We can count them and look at them and so forth. So we get something like, well, I exaggerated that a little bit, but whatever. So the average height of men is here. Now, this average is higher than this average. That's all this means right here, that the average height of men is greater than the average height of women. Now, this difference is small. It's small in a relative sense. It's small in a relative sense because we could look inside the distribution of men, and we see that this distribution, the distribution of differences within men from here to here, is large. And the same thing in women. The difference between the tall and the small and all this kind of stuff is also large. But the difference between the two is small. So you'll see some people say, particularly when it has to do with other characteristics, well, because this is smaller than this, there is no real difference. Statisticians make this mistake. When we change this to a political thing, not height is not so political. It is a little bit. Everything is turning into politics nowadays. It's not as political as, say, intelligence. And we're using other characteristics. We could use sex, we could use race, we could use other things. And then all of a sudden, people make these kind of dumb errors. They say, because this thing is small and this is large, well, there's no differences. Well, that's not true. It's just obviously not true from the picture. So if they were to draw the picture up, we're going to try to do as much as we can. We're going to do a lot of math coming up soon, starting next week. We're going to do a lot of math. But every time we could use a picture, I'm going to, because they're so much more intuitive. Now, that's basically it. I've got a lot more in the book, and you could read. Look at this, the size of these things. This thing is a huge. It's just a lovely book too, Gork's book, and you could read all that. And you could read Stowe's book and everything if you're really interested in these topics, and get a lot more insight than I'm giving you in this half hour here and a brief reading assignment. Now, what about homework? I don't have homework. I mean, you can, I'll think of some homework and I'm going to put it under the video in the description. If you're watching this on YouTube, it'll be in the description, or on Rumble, it'll be in the description. It'll be right about where the videos are on the blog or on Substack or something like this. I haven't made up my mind clearly about what kind of homework you could do on this besides just the reading. That's it for now. Next week we go back to Jane's and we start talking about we're gonna prove that probability is a number and between 0 and 1. Simple as that. Okay. See you next week.